Right now, in some states across this country, a barrel sitting under a downspout is a criminal act, not a gray area, not a nuisance violation, a crime with documented fines reaching hundreds of dollars per day for homeowners who dared intercept the rain falling on their own roofs. Water that struck your shingles, ran through gutters you installed, on land you pay taxes on, legally belonged to someone else the moment it left the sky. Think about that for one full second. The water cycle delivered something free directly onto your property, and a law written in the 1800s decided it was not yours to keep. 4,000 years ago, the Nabatean civilization in the Negev desert had already solved every water problem you will ever face, using sloped rock catchment channels that fed underground plaster-lined cisterns holding up to 50,000 liters, with no pumps, no permits, and no monthly bill arriving in the mail. The water utility lobby made sure most Americans never learned it was legal, or how to do it. By the end of this video, you will know exactly which states banned rainwater collection, why those laws exist, and the fully legal workaround that lets you collect, store, and use rainwater starting this week. I'm your host, and welcome to this channel. Subscribe, because what the utility lobby hopes stays forgotten, we cover every single week. To understand how catching rain became illegal, you have to go back to the true beginning, to the moment humans first understood that the sky was a free water system, and that the only technology required to use it was gravity and a container. The Negev desert receives less than 4 inches of rainfall per year. 4 inches. And yet, in the ruins of Nabatean cities like Avdat and Shivta, archaeologists have documented elaborate networks of sloped stone channels, rooftop collection surfaces, and underground cisterns with smooth lime plaster interiors engineered to minimize evaporation and contamination. Ben-Gurion University researchers studying these systems found they captured and stored rainfall with an efficiency that modern engineers describe, with some professional embarrassment, as elegant. The Nabateans were not primitive. They were precisely calibrated. Every surface angle, every channel width, every cistern depth was a deliberate engineering decision made by people who understood that in a desert, water is not a convenience. It is the entire civilization. They built permanent cities in one of the driest regions on Earth and sustained them across centuries. And they did it by refusing to waste a single drop of what the sky periodically and generously delivered. That is the origin. Simple. Ancient, fully documented. They built cities in the desert on nothing but rain. Then we made it a crime. Here is the number that changes everything. Every 1,000 square feet of roof surface collects approximately 600 gallons of water per inch of rainfall. A standard 2,000 square foot American house, under 1 inch of rain, generates roughly 1,200 gallons of harvestable water. The average American household uses approximately 100 gallons per day for all indoor purposes. 1 inch of rain on a typical suburban roof produces 12 days of household water equivalent. The physics is not complicated, not new, and not disputed. It was understood by the Roman curator Aquarum, the municipal water overseers who managed Rome's vast aqueduct networks, and documented with precise engineering detail by the architect Vitruvius in De Architectura, a text that describes rooftop water collection as a standard, expected feature of Roman residential design. The Roman impluvium, the deliberate open sky courtyard inset built into the center of a Roman house, was not a decorative flourish. It was a precision catchment surface, sloped at a calculated angle, feeding rainwater through terracotta pipes roughly 6 to 8 inches in diameter directly into sealed underground cisterns beneath the home's foundation. Every Roman house of any substance had one. No pump, no municipal connection, no invoice arriving at the end of the month. The math works everywhere. The law, in some places, does not. This is where the first twist lands, and it is heavier than it initially sounds. Rainwater collection is not a fringe idea, not a survivalist fantasy, not an innovation of any kind. It is the original human water infrastructure, the system that predates every pipe, every pump, every centralized treatment plant, every water meter, and every monthly bill by several thousand years. The principle is embarrassingly simple. Precipitation falls on an impervious surface. Gravity pulls it in one direction. A container waits at the end. The staggering magnitude of what this replaces, an entire industry built on monthly metered consumption, is not a coincidence. It is the tension at the center of this entire story. It worked for 4,000 years, until someone built a billing system around the river. In colonial America and across the 19th century American frontier, every farmhouse in regions without accessible rivers or reliable wells maintained a system. cistern. USDA agricultural circulars from the 1880s and 1910s routinely described cistern construction as fundamental homesteading knowledge, placed in the same practical category as building a smokehouse or digging a root cellar. Great Plains settlers caught rain in wooden barrels, graduated to brick-lined cisterns with hand-pump delivery systems, and relied on this infrastructure not as a backup measure, but as their primary household water source for entire generations. The first flush diverter, the mechanism that automatically discards the first contaminated wash of water off a roof surface before directing cleaner flow into storage, appears in agricultural extension guides from this era. Described plainly and without ceremony, it was standard knowledge, widely published, actively taught to farmers across the country. Every American farmhouse had one. Then the pipes came, and the bill came with them. Understanding how rainwater collection went from standard agricultural knowledge to criminal act in certain states requires going back even further, now to the legal architecture of the American West, and to a doctrine that shaped water rights in ways most homeowners have never once encountered. The prior appropriation doctrine, developed in western states during the mining and ranching booms of the 1800s, established a single governing principle: first in time, first in right. If you filed a legal claim on a water source before anyone else, that water was yours, including the precipitation runoff that eventually flowed toward your claimed waterway. Ranchers and agricultural interests in states like Colorado filed prior appropriation claims on rivers and streams, and over time, legal interpretations extended that doctrine to include surface water runoff, the precipitation that fell on distant hills, rooftops, and farmlands, and eventually fed those claimed downstream sources. Under this legal framework, a Colorado homeowner catching rain in a barrel was technically intercepting water that downstream prior claimants held legal priority rights to receive. It sounds, in the context of a suburban neighborhood, completely absurd. Colorado's water law enforced it for over a century regardless. The law was not written to protect you, it was written to protect the rancher who owned the river downstream. Then the second enemy arrived, and this one had a significantly larger budget and a more sophisticated mechanism for shaping public policy. Beginning in the 1930s and expanding aggressively through the post-war decades into the 1960s, federal infrastructure investment funded the construction of centralized municipal water systems across the country at an unprecedented scale. These systems were genuine engineering achievements, legitimately useful, capable of treating water at scale and delivering it reliably to millions of homes. But they were also revenue systems with fixed infrastructure costs that required consistent metered consumption to remain financially viable. The per-gallon billing model required connection, and it required ongoing use. Industry associations representing utilities shaped building codes, municipal standards, and infrastructure investment priorities in ways that made central grid connection not merely convenient but legally mandatory in most jurisdictions. Decentralized rainwater collection was not banned in every state, but it was made progressively invisible. Unlicensed, unacknowledged in building codes, absent from architectural education, ignored in municipal planning documents, and unavailable as a permitted option in most building departments. The moment your house was required to connect to the municipal line was the moment your roof stopped being yours. Colorado formalized this suppression most explicitly. Until 2016, the collection of rainwater was effectively prohibited statewide under prior appropriation water law. Then Colorado House Bill 16-1005 passed, and the state legislature made a partial and carefully bounded concession. Homeowners may now collect rainwater, but only in 2 containers, with a combined maximum capacity of 110 gallons. 110 gallons. On a 2,000 square foot roof, a single inch of rain produces 1,200 gallons of collectible water. The state's legal maximum captures roughly 9% of what one ordinary rainstorm delivers onto a standard suburban home. Utah allows collection up to 2,500 gallons with registration. As of the most recent legislative reviews tracked by the National Conference of State Legislatures, some states still carry meaningful restrictions on the books. They didn't need to hide it, they just needed to make you need them first. And here is twist 2, and this is the one that reframes every piece of the story you have just heard. This was not a conspiracy. Nobody gathered in a room and drafted a plan to steal your rainwater. What happened is far more ordinary and far more insidious than that, which is precisely why it persisted without public outrage for so long. A legal doctrine designed for 19th century ranching economics was simply never updated for the reality of 21st century suburban home ownership. A utility industry built entirely on metered per gallon consumption had no financial interest in funding the research, education, or regulatory framework that would enable citizens to partially exit that billing relationship. Building codes written by committees that included utility sector representatives had no existing checkbox for rainwater harvesting systems, which meant inspectors had no framework to approve them, which meant builders had no contractual reason to include them, which meant architects stopped drawing them, which meant engineers stopped specifying them, which meant homeowners stopped knowing they existed. The passive system was not disproven by science. It was excluded by economics. It was not destroyed by regulation. It was made inconvenient to approve. That is the level of structural suppression that feels mundane rather than dramatic. And that is exactly what makes it so completely effective. Now, here is what a modern rainwater harvesting system actually looks like in physical and mechanical terms, because this is where the practical reality becomes impossible to dismiss or minimize. The roof surface collects precipitation and feeds it into conventional gutters. The gutters carry the water flow to a first flush diverter, a simple and inexpensive pipe mechanism that automatically diverts and discards the first flush of rainfall, calculated at a standard specification of approximately 1 gallon of diversion capacity per 100 square feet of roof catchment area. That first flush carries the accumulated bird droppings, atmospheric particulate, oxidized roofing material, and whatever else settled on the surface between rain events. After that initial diversion, the cleaner subsequent flow is directed into the storage tank, typically manufactured from food-grade polyethylene rated for potable water contact, available in sizes from 50 gallons up to 10,000 gallons or more. A 1mm mesh screen covers every tank inlet to physically block mosquito access and eliminate the breeding risk that regulatory bodies most frequently cite as their primary objection to these systems. An overflow pipe sized to match the inlet diameter directs excess capacity away from the foundation to prevent water intrusion. A sediment pre-filter removes suspended particulate from incoming flow. For outdoor irrigation, which is the legal baseline available in effectively all 50 states, this is the complete system. A $300 barrel and a $12 diverter. That is the entire technology. The Texas A&M AgriLife Extension Program has published detailed engineering guides for exactly these systems, and the American Rainwater Catchment Systems Association, known as ARCSA, maintains formal installation standards under certification reference AP114. In Texas, where no state-level restriction applies to rainwater collection, ARCSA certified installers have documented complete whole house systems, incorporating 10,000-gallon polyethylene storage tanks, sediment pre-filtration, UV disinfection units, and pressure delivery pumps, with total installed costs documented in the range of $8,000 to $15,000 depending on system scale and site conditions. Households operating on these full systems report zero recurring municipal water bills after the initial installation investment. In Texas, it's not just legal, it's a certified system with published state engineering standards. The physics did not change, the zip code did. In the states maintaining active restrictions, utility interests and allied regulatory bodies have deployed a safety argument that sounds, on the surface, entirely reasonable. Rainwater, they correctly note, can carry contaminants picked up from rooftop surfaces during collection. Without treatment, it may not meet safe drinking water standards. Poorly maintained open containers can create mosquito breeding habitats. These concerns are real, technically accurate, and completely manageable. They are addressed by a first flush diverter, a 1mm inlet screen, and a basic sediment filter, equipment that costs less than a single month of the average American household's municipal water bill. The contamination argument would be considerably more convincing if it were applied with equivalent rigor and equivalent regulatory energy to municipal water systems, which have documented their own contamination incidents across hundreds of American cities over the past 2 decades. The argument is not applied equally. It is deployed selectively in the context of a legislative hearing by a representative whose campaign has received financial support from the utility sector against a specific bill that would permit what an inexpensive barrel and a $12 fitting can already accomplish. This is not theory. This is the documented legislative record in multiple states. And then you look at Germany, and the argument against rainwater collection collapses entirely under the weight of publicly available evidence. Germany has standardized rainwater harvesting under DN 1989-1, a formal national building standard that specifies system design requirements, tank sizing calculations, pipe materials, filtration specifications, and mandatory maintenance intervals for both residential and commercial installations. European Industry Association estimates suggest Germany has installed well over 1 million residential rainwater harvesting systems, a figure that has grown consistently across monitored years. German residential buildings routinely incorporate dual pipe distribution infrastructure, one line carrying treated municipal water for drinking and cooking, a second dedicated line carrying harvested and filtered rainwater for toilet flushing, laundry machine supply, and outdoor use. Toilet flushing alone accounts for approximately 30% of total household water consumption. Offset that single demand category with harvested rainwater, and the documented reduction in municipal water consumption across monitored German installations runs between 30 and 50% per household annually. No public health crisis followed the adoption of this standard. No contamination epidemic appeared in the epidemiological record. Singapore's Public Utilities Board has integrated rainwater harvesting directly into its national water resilience strategy alongside NEWater advanced water recycling systems, successfully managing one of the most densely populated and water-stressed urban environments on the planet with documented operational success across multiple decades of continuous monitoring. The data is public, the engineering standards are written and freely available, the buildings are operating right now. The workaround is not experimental, it is German National Building Code, and it has been for years. Here's what you can do right now, today, regardless of which of the 50 states you live in. Outdoor irrigation collection is legal with varying volume limits in effectively all of them. Check the National Conference of State Legislatures database, which maintains a current and regularly updated state-by-state summary of rainwater collection statutes. It is a publicly accessible government resource and the most reliable single reference for your jurisdiction's current legal limits. In most states, a system using between 50 and 300 gallons of storage capacity for garden and landscape irrigation requires no permit, no registration, and no inspection of any kind. Install a first flush diverter rated at 1 gallon of diversion volume per 100 square feet of your roof's catchment area. Cover every inlet with 1mm mesh screen. Direct the overflow pipe, sized to equal your downspout diameter, away from your foundation at a minimum slope of 2%. Your payback period on a basic outdoor irrigation system measured against reduced municipal water costs for landscape use typically runs between 1 and 3 years depending on your local water rates, your annual rainfall totals, and your current irrigation consumption. In states with higher legal storage limits, scale the system proportionally. In Texas and other unrestricted states, the ARCS AAP 114 certification standard provides a complete engineering specification for a full whole house system with potable treatment capability. You do not need to move states. You need to know exactly which container size is legal where you live, and then you need to build it. The average American roof, depending on climate zone and annual precipitation, receives somewhere between 40,000 and 100,000 gallons of rainfall per year. That number has not changed. The water cycle does not consult zoning boards before delivering precipitation. The prior appropriation doctrine cannot alter atmospheric physics. The utility meter cannot reach the sky. The Nabateans in the Negev desert understood all of this 4,000 years ago, cutting channels into desert limestone at precise calculated angles, feeding cisterns that kept entire cities alive through decades of near zero annual rainfall. The Romans understood it, building the impluvium into the architectural blueprint of every house as the first and most fundamental node in a domestic water system requiring no external infrastructure beyond gravity and fired clay. The American frontier understood it, publishing cistern construction as essential survival knowledge in every agricultural extension bulletin for half a century. Then the pipes came, then the building codes arrived, then then the monthly bill became the only model anyone was allowed to use. But the rain kept falling. It falls on your roof right now, at this exact moment, running through your gutters, hitting the ground, entering the municipal drainage system, and eventually returning to you through a meter that measures every gallon and charges accordingly. The sky still delivers. The only question is whether you have made it legal to catch what was already yours.